All right, good afternoon, class. How's everyone doing?
Good.
Good, good. Okay.
Good.
Sorry if the timing here is, if you were watching the presidential address at all. But I guess we're going to continue with class, obviously. We have a quiz today over 2.3. I kind of promised you that would happen. And then we're going to do product and quotient rules, 2.4, next time chain rule. On our calendar, we're supposed to have a test on Tuesday, right, March 1st. But we're gonna move that. We don't have enough material right now to have a test. So we're gonna move it to the Thursday before spring break. I believe that is correct. Let me double check. Yeah, spring break starts on the week of the 15th. So yeah, we're gonna move it to the 10th. And by doing that, we should be able to get most of chapter 2 in. Okay, we should be able to we'll see how we do on related rates. That usually takes 2 full classes. So that's the plan. Any questions? No? Okay, so the quiz is just going to be a poll. So you're just going to answer 2 questions. There's 4 choices for each question. So let me get the poll launched first. 2 questions. Okay, there's the poll. If for some reason your poll's not working, make sure that you send me your answers in the chat. All right. So here's the quiz. Can everybody see that okay? For each of these functions, I want you to find the derivative applying the power rule. Enjoy. Okay, everyone, it's been about 6.5 minutes. We'll go just another minute or so. Okay, everyone, 20 seconds. I'm going to close the poll. Okay, so let's take a look. Looks like for number one, we had about maybe kind of a mix there. But yes, D is the correct answer on number one. So I'll run through it real quick. We have five. Well, first of all, we have three terms, right? So we can take a derivative of each one individually. For the first one, we can bring the 5 along. So I just bring the 5 down, and then I bring the 4 out, 4, and then I subtract 1 from 4 and get 3. So that's going to wind up with 20x cubed, which all of these had 20x cubed. And then the next one, I bring the -3 down. And then when I take the derivative of x to the -3, I drop the -3 out front. And then I subtract 1 from -3. So -3 take away 1 is -4. And then these two numbers multiplied together to be 9. Okay, so we have a 9x to the -4. So it can't be this one or this one. And then lastly, I do plus, and then 7 comes for the ride, and then the derivative of sine of x is cosine x. So it's not this one because this one has -7, so it's D. Now the second one, the first thing you have to do is rewrite this as 4 over x to the half minus 10x to the 3/5. And then you could go even further and bring that x to the half up as an x to the -1/2 minus 10x to the 3/5. And then you start with the derivative. So you bring the -1/2 out in front. Let me do that over here. So for this one, you bring the 4 along for the ride, -1/2 comes out, x, and then you subtract 1 from -1/2 and you get -3/2. And then on the second one, the -10 comes for the ride, and then the 3/5 comes out. So times 3/5 x, and then you subtract 1 from 3/5 and you get -2/5. And then there's just some cleaning up to do. These two together are -2. And then this together, you get -6 there. So -2x to the -3/2 minus 6x to the -2/5. And that's this one here. Okay. Any questions? Let's see what happened on the second one. Yeah, so a lot of people thought C for the second one. It was pretty much just, it's either A or C on. So what's the deal with this one here? The 1/2. I'm guessing that the people who did C forgot that this x to the half was on the bottom, and that you have to bring it up first as an x to the -1/2. So they probably took the derivative x to the half brought the half out, but then how would you get the -2? That's a little weird. Yeah, not sure. Anyone want to comment on that? No. Okay, well, we move on, yes? All right, any questions over homework or anything else before I start today's material? We're okay. All right, so we established last class a bunch of rules, right? Derivative of a constant by itself is 0, derivative of x is 1, the derivative power rule, right? We got the power rule, we got the sum and difference rule, right? We had all these different basic ideas. Today we talk about how do you take the derivative when you have a product, multiplication between two functions. And then after we do that, we're going to talk about how do you take the derivative when you have a quotient or division between two functions. So look, if we take two functions, let's say f, and we multiply it times g, and we want to take the derivative, it would be really, really nice, right? Life would be really, really good if this is all it was. If you just take the derivative of each one separately. I mean, that's what happens when you have addition and subtraction, right? If you have addition between two functions and you take the derivative, you can separate it and do it individually on each function. And if you have subtraction, you just do them individually and just keep the subtraction between them. So this is good, right? We're happy about this. When it comes to multiplication, it would be nice if that's the way it was as well, but it is not, okay? It is not this. In fact, if it were this, calculus would not be as hard as it is. And Cal 2 would be much easier than it is. But, you know, that's not the way it is, right? So what is it, right? That becomes a question. What is it then? Well, I'm going to give you the rule. Okay, now I'm not going to prove it to you unless we have time to prove it. I would have to do it at the end of class. So here's the rule, all right? In fact, I'm going to erase this because I don't even want it on. Well, I don't even want it there. Okay, if you have a function f multiplied by a function g and you want to take the derivative, what you're going to have to do is this. You're first going to take the derivative of f, okay? Then you will multiply times that g, but you will not take the derivative of g. And then you will add to that. Now you take the derivative of g, and then you multiply that times f, but you don't take the derivative of f. So it's like you do them one at a time. First, you do the f function's derivative, but keep it multiplied times g, and then you'll add to that the derivative of the g, but not the derivative of the f. So I like to kind of explain this rule in words, okay? So you're basically going to take derivative of first times the second plus the derivative of the second one times the first. Okay, that's kind of like what's happening. You're taking the derivative of the first times the second plus the derivative of the second one times the first. I like to memorize it, try and memorize it this way, because then you don't need to think about f and g. You're just thinking, okay, if I have two functions being multiplied, I'm going to take derivative of the first one, multiply it times the second one. Then I'm going to add to that the derivative of the second one, then times the first one. All right. Y'all got it? I want to warn you right now that if you go to your formula sheets, this is in your formula sheet, but let me clear all this out of here. It's called the product rule, and it's right here. I want to copy it, and I want to explain what's happening with this and why it's different than what I put on the up here. So in the book, this is the formula they use. So the way to read this, the way the book is doing this is they're saying, hey, if you want to take the derivative, right, of two functions being multiplied, that's like f times g, They're saying, hey, if you want to take derivative of that, then what you're going to do is f times the derivative of g plus, and then they write g and then times the derivative of f. Do you see how that looks different than what I'm showing you? Okay, there's a reason why I do it this way, all right? And I'll explain it to you when we get to the next rule. But I just want to point out that these are the same things, right? Because in this first one, it's the derivative of f times g, and that's this. And remember, with multiplication, it doesn't matter what order you multiply things. And then this one is actually this, but again, the order can be switched. And then with addition, you can switch. So that's the way the book presents it. That's the way most textbooks present it. Again, I will explain why I do it this way, you know, in a little while. All right, you ready to see it in action? Let's do it. Let's do some examples. All right, so for your first example, let's say that you have some function f of x, I hate this thing, f of x equals, let's start with x squared sine x. And I want us to find f prime of x. So I have to look at this and I have to realize that there's a product here, right? There's a product right there. Even though it's not written, there is a implied multiplication right in between these two things. And so if I'm going to look at the formula, I need to identify that this first one here is kind of like the f, and the second one is kind of like the g. I have two functions of x that are being multiplied together, and I'm trying to find their derivative. So according to the formula, right, the derivative of f times g will be the derivative of f times g plus the derivative of g times f. Okay, so that's what I'm about to use. So now I go for my derivative here. The derivative of this will be, okay, I need to take the derivative of f first, right? That's what I need first. So I'm not going to do the derivative. I'm actually just going to symbolically show you that I need to take derivative of that one and then multiply it times sine of x, which is the g function, and then add to that. Then I take the derivative of the sine, which I haven't done yet. I'm just showing you symbolically that I'm going to, and then times the f function, which is x squared. So does everyone see? This is f prime, g being multiplied plus, and then g prime times f. Does everyone see that? Yes? Now we actually take those derivatives. There's two derivatives we have to take. So when I take the derivative of x squared, I get 2x. That's the power rule from last class. Then times sine x. And then plus, now I take the derivative of sine x, which is cosine x from last class, times x squared. And that's the derivative. We're done. Now I am going to do one more thing though. On this second factor right here, I'm going to put the x squared in front of the cosine of x. And the reason I'm doing that is because I want to be clear that this x is trapped in the cosine, and I don't want anyone to accidentally do this and write that as cosine of x cubed, because these x's are not being multiplied together. This x is trapped. It's the argument of the cosine function. This x squared is a separate function, and so I'm just going to slide it out front to make it so that there's no mix-up. Any questions there? Okay, let's do another one. How about this? How about h of x? I'll just use a different variable here. H of x equals, how about x cubed plus x squared plus x plus 1 times x to the fourth minus 3x squared plus x minus 7. I want us to find h prime of x. So I want the derivative of this. So you cannot just take the derivative of these individually and then take the derivative of these individually and then multiply those two answers together. You can't do that. And the reason you can't do it is because, well, we have multiplication, right? And anytime we have multiplication between two things, we must follow the product rule. So I'm going to first identify the product here, right? I need to make sure I understand there's a product. So I'm going to employ the product rule. And I'm going to say this whole thing over here is like my F, and this whole thing over here is like my G. And then I'm going to apply the rule. So the derivative of H will be, and I'm going to write this out symbolically again first. I first need to take the derivative of the first function. So I need to take x cubed plus x squared plus x plus 1. I need to take its derivative. Then I'm going to multiply that times g without taking its derivative. And then add to that, now I take the derivative of g. So I'm going to write g down. I need to take its derivative and then multiply that times f without taking the derivative of f. I realize this is a lot, okay? That's what it is, okay? That's what the derivative will be. So I have now two derivatives to take, right? Those two. And then those other pieces, I'm not going to do anything with them. So here we go. In parentheses, the derivative of this should be 3x squared plus 2x plus 1. And that's from last class. I'm applying the power rule on those. 3 comes out, subtract 1 from 3, you get 2. 2 comes out, subtract 1 from 2, you get 1. The derivative of x is 1, and the derivative of 1 is 0 because it's a constant. Next to that, I write x to the 4th minus 3x squared plus x minus 7, then plus, and now I need this derivative, so I'll apply the power rule again. So we get 4x cubed minus 6x plus 1, and then the f function at the end here. There, that's it. Derivative of these four terms, I did them individually because, well, I'm allowed to because all I'm doing is taking derivative of what's in here. And then I just use power rule on each of those. And the derivative of -7 was 0. Any questions there? I'm going to leave our answer like this, okay? That is the derivative, all right? Yes, you could multiply that all out. Yes, you could multiply that all out, expand everything out and collect like terms. But for us, we're just, when we're doing these sections, we're just going to leave these derivatives kind of in this form. We're not going to try and simplify them. And I call this the raw derivative, okay? In other words, the unsimplified, the raw derivative. I'm not cleaning it up. I'm not doing any more algebra to it. I'm just giving you what the derivative looks like right after I do the differentiation. On your exam, for a lot of the questions, I'm just going to ask you for the raw derivative. That way you're not wasting time doing algebra. Questions on this rule? We got to do a couple more, right? How about this one? What if I tell you g of theta is equal to theta tangent theta minus 2 cosine theta plus theta cubed? And I ask you to find g prime of theta. All right, so I'm using theta instead of x, right? Okay, fine. All right. It's just a variable, right? Theta is just a variable. So I'm going to just do everything the way I've been doing. I look at it first, and when I look at it, I actually see that I have 1, 2, 3 terms, right? Separated by addition and subtraction, which means I can take the derivative of each of these separately, right? I'm allowed to do that. I can do them individually. So let's look at them individually. When I look at theta tangent theta, if you were to read that, right, you would say theta times tangent theta, right? That's what's happening here. Theta times tangent theta. There is a multiplication here, which means when I take the derivative of this, I'm going to have to employ the product rule on that. Now for this one, when you read this, it's 2 times cosine theta, right? There is a multiplication here, but I do not need the product rule. Why? Why do I not need the product
Because
rule?
it
It's a
don't have
constant.
constant.
That's right, because it's a constant in front of the function. And we know that the constant just comes for the ride. So I can just bring the two down and take the derivative of cosine separately. All right, so I do not need a product rule here. See, here I do, because theta is not a constant, right? Theta is a variable. This is a variable, this is a function of theta times some other function of theta. You must use product rule. Here, constant times function of theta, you can just bring the constant down. Here, power rule, right? I'll just do the power rule on theta cubed. Okay, so let's do this. I'm going to do this like scratch work on the side. The only thing that's requiring me to really do any sort of product rule is the theta tan theta. I want to know what the derivative of this is. Well, according to the product rule, if I treat this first one kind of like the F and this one like the G, then it's going to be the derivative of the first one. So this should be equal to the derivative of the first one times the second one plus the derivative of the second one times the first one. What is the derivative of theta?
Secant squared.
Theta, not tangent theta.
Oh, tangent. One.
Secant square.
No, it's one.
The derivative of theta is just one. That's like me saying, what's the derivative of x? So we learned that last class, the derivative of x would just be one. So this is just going to be 1 times tangent theta. I'm not touching that tangent. Plus now the derivative of tangent theta from last class is secant squared theta. I never proved that to you. I told you you just need to know it. And then times theta, which I can clean up to be tangent theta. 1 times tangent theta is tangent theta. And then on the second one, again, I'm going to pull that theta out in front of the secant squared theta. That way you don't accidentally try and put these two thetas together, because that theta is trapped inside the secant. So that is the derivative of the first term. So I think I'm ready to write everything down here. G prime theta should be the derivative of this, which I just found out over here was tangent theta plus theta secant squared theta. Okay, that is just the derivative of this. And then this one, you have to be a little careful on this one because the -2 comes for the ride. But what's the derivative of cosine theta?
Negative sign.
Negative sine theta. So I'm going to put it like this, negative sine theta. And those two things are being multiplied so that those two negatives are going to come together and become a plus. And then I still have 3 theta squared. So I guess we could just do one more line, tangent theta plus theta secant squared theta plus 2 sine theta plus 3 theta squared. That's the derivative. Questions? All right. Let's keep rolling here. How about this one? What if I give you d of t equals square root of t secant t, and ask you to find d prime of t. I'm going to give you a few minutes, see if you can figure this one out. Just get the raw derivative. You don't have to do any algebra after, just try and see if you can get the raw derivative. You need to know the derivative of secant t. So you might need your formula sheet if you haven't memorized it. Why don't you let me know if you finish? I'm going to send out a poll. Yeah, so just let me know yes when you have finished this one. We'll go 30 more seconds. I've only got 8 of you done. So let me call on somebody. How about Leonard? Are you there? Leonard?
Yes, I'm here.
Were you able to get it?
Yeah, I got, well, not the whole thing yet.
Okay. So you see the product, yes?
Yes.
Okay, so you got F and then you got G. So let's follow the product rule. So the first thing you have to do is give me the derivative of F, then multiply that times G, then add to that the derivative of G, then multiply that times F. So what would be the derivative of F? So what's the derivative of the square root of T? Leonard, no?
It was T 1/2.
What is that?
T exponent to 1/2.
That's what, yeah, that's what this is, right? This is actually T to the half. I agree with that, but what is the derivative of it?
1/2 T 3 2.
It's 1/2 times square root of T.
Yeah, y'all remember me talking about this last time? I said this is one of those ones that you should just be automatic with. Like, don't, Bellum, it's not wrong to do this, okay? It's not wrong, but this happened, square root of T or X comes up so much that this is just something that we should be, go right to the derivative automatically. That should just be 1/2 root T, right? 1/2 root T. That's the derivative of F. Then times G, so secant T. And then plus, now the derivative of F, I'm sorry, the derivative of G. So what is the derivative of G? Let's see. Enrique, are you here?
Yes.
What's the derivative of secant T? Did you look it up?
Yes, I got secant T times tan T.
Secant T tan T, good. It's a weird derivative, right?
Yeah.
Secant T times tangent T. And then you still need to slap onto the end of that f, right? Which was square root of t. And this is it. This is your raw derivative right here. Yes, you could do some things like maybe you could write secant t over 2 root t, like you could combine those two together like that. And then on the second one, maybe you move the root t out to the front. Like that, that would be better looking. You could get a common denominator. We probably wouldn't want to do that right now, but later on, we will be getting common denominator on this. We're going to find out later that on all these derivatives that we are doing, we're going to be wanting to set them equal to 0 and solve. So we're going to be solving equations later, set it to 0, solve it. And so we're going to have to do algebra later, but for now, we just want to make sure we can get the derivative right. Okay, let's see. How about this one? If f of x equals sine x cosine x, find the equation of the tangent line at 0, 0. Okay, so this takes us back to a few sections ago. This whole idea of finding the equation of a tangent line is kind of at the heart of what we're doing here in chapter 2. And so we know that to do this, well, we should know that to do this, we're going to have to bring out that good old point slope formula to find the equation of the tangent line. The x1 and y1 here is the point that's given to us. So we know that this is y minus 0 equals m times x minus 0, which really is just y equals m times x. The only thing we have to really determine is this, and that is the slope of the tangent at x equals 0 coming from right there, which means we need to figure out the derivative of this function at 0. Which means we need its derivative first, right? Like we need to take the derivative and then plug 0 in for x. So when I take this derivative, again, I have to recognize I have a product here, right? I have a product. So I'm going to have to do the product rule. That's my f, that's my g. And then I just use the rule. So let's see, maybe I can just call on somebody and they can tell me. Let's see, Duck, you there?
Yes, I'm here.
Okay, how comfortable are you with just reading out the derivative without actually having to show me like, oh, we're gonna take derivative of this and then this. Can you just do it mentally?
I don't think so.
No? Okay, so we're gonna do the derivative of f times g plus derivative of g times f, right? So what's the derivative of f?
Cosine x.
Cosine x. Okay, so that's cosine x times what's g?
Cosine x.
Cosine x again. Okay. Plus, now what's the derivative of g?
Sine x.
Negative, right? Negative sine x. So derivative of cosine x is negative sine x times what's f?
Sine x.
Sine x. So we get cosine squared x. And then when you put these two together, you have a positive and a negative being multiplied, so you get minus sine squared x. And be careful, everyone, that is not, that is not 1. If that were a plus right here, then it would be, that the answer would be 1 because of the Pythagorean identity. Sine squared x plus cosine squared x equals 1. But that is not the case when you have a minus. So that's our answer. Now, that makes sense, everyone? James, are you there? Is James here?
Yes.
Okay, James, there you are. So what do I need to do now? I have the derivative. What do I need to do to this now?
Plug in 0.
Plug in 0. Okay, so let's do that. If we take 0 and we plug it in, we get, now we have to understand what cosine squared x means, right? This does mean cosine of, we have to plug in the 0 first, right? For x, and then whatever we get, we're going to square that answer. And then we're going to do sine of 0, and then whatever that is, we're going to square the answer. And by now, we're all comfortable knowing what sine of 0 and cosine of 0 is, I hope. Cosine of 0 is
1.
1, and then 1 squared is 1. And then minus sine of 0 is
0.
0.
0, and 0 squared is 0, so you just get 1. Which means now we can come here and get the final equation. It's y equals 1x, or just x, right? Y equals x. Y equals x. Questions? Let's take a look at this. I'm going to graph this function. The function was y equals sine x times cosine x. What's going on here? Why is it not taking that? Sine x, cosine x. Something is not right there. It doesn't look right. Let me see. Okay, yeah, times cosine. It almost looked like a sine function. Okay, there's the graph of the function. And then we were looking at the point 0, 0, right? We were looking right there. And we were trying to find the equation of the tangent line. And we got y equals x. And I think you would all agree that that is the tangent line that goes through that point, runs tangent to the curve. Right? That's what we just did. Okay. Ready for a harder one? Let's say f of x equals x cubed sine x cosine x. Find f prime of x. I just want the derivative. So do you all agree that we actually have two products? We have two products, don't we? We have x cubed, then times sine x, then times cosine x. And right now, we don't have a rule for that. We only have a product rule that deals with two things being multiplied. Do y'all agree? So to do this, here's what I'm going to do. I'm going to pick one of these. I think what I'm going to do is I'm going to pick right here. I'm going to treat that as the product. I'm going to call the x cubed the f. And all of this together, including the product, I'm going to call that g. All right. So the derivative of f should be whatever f prime is times g plus whatever g prime is times f. Do y'all understand what I'm doing here? I'm saying, okay, I'm going to treat the first factor is f, and these two factors together, all together, are going to be g. And then I'm going to apply the product rule on these two pieces. So what is f prime? We start here. What is f prime?
3x squared.
3x squared. And then I multiply that times g. What's g?
Sine x times cosine x.
Sine x cosine x, right? So I'm done with the first part. Y'all see that? But now what do I need? G prime, right? I need the derivative of this, right? I need the derivative of that. But guess what? That's a product, which means I would need to go to the side over here and figure out, right? If I'm saying G is sine x times cosine x, and I'm trying to find the derivative of that, right? I want the derivative of that. Then I'd have to apply a product rule here, wouldn't I? Now, we did that just now, right? Didn't we just do this problem? So I'm not going to repeat this work. This is what we need to do. And we got cosine squared x minus sine squared x. That's what we got, right? For the derivative. So here, we already know that this is going to turn out to be cosine squared x minus sine squared x. That is what the derivative of g is. So that's going to get plugged in right here. Cosine squared x minus sine squared x. But what do I still have to attach to the outside of that?
X cubed.
X cubed. See, I have to finish off the product rule. I still need the f. So I'm going to put my x cubed there. That's weird, right? So you actually have like what we would consider to be like a triple product, right? It's three things multiplied. So what you do is you split it. At one of the products, you split it. Then you run your product rule on that. But within that product rule, there's going to be another product rule. You see that? It's like we had a product rule within a bigger product rule. Okay. We won't go past triple products, okay? Theoretically, you could do four things multiplied together as well. But in this class, in this textbook, we never go past three. All right, making sense? How are y'all feeling about this? Does this feel comfortable or does it feel awkward? Okay, all right. I'll take silence as everyone's
I just feel like you have to be like really meticulous with one, so you just mess up the second one, having the first one wrong. Yeah.
There's all these little places where you can make mistakes. Just you have to keep track of this derivative formula, right? And just make sure you're taking each of those derivatives, you know, cleanly. Also, notice I put on the G prime, our answer had two terms in it, right? And that's why I put it in parentheses, because this x cubed has to multiply times G prime. So it would have to multiply through to both of these. If I were to algebraically clean this up, if I leave the parentheses off here, it's wrong. It's wrong because this is implying that the only thing the x cubed is touching is the sign. You have to have this here so that you have the full x cubed applied to the entire G prime. Well, I left that squared off. Did I erase that squared or what? Did I forget to put it initially? I don't remember. I may have just erased it. Yeah, that's the product rule. You ready for quotient rule? Let's do quotient rule. So here's where we are. If I have f times g and I multiply them together and I want to take the derivative, it's going to be derivative of the first one times the second plus the derivative of the second one times the first one. That's our product rule. And everyone's happy with it. Just need to go get some practice, right? Just practice with it. Now we move to quotient rule. So the question becomes, what if instead of multiplication, we have division? We have f divided by g, and we want to take its derivative, right? Well, just like the product rule, you wish it was this, right? That would make life good. That's not it though, okay? That is not it. So you ready for the formula for quotient? Here it is. It's the derivative of f times g minus the derivative of g times f. Look familiar? That's the product rule, right? But with a minus in between instead of a plus, right? One more thing. You have to take the whole thing and divide it by g squared. And that's your product rule. Again, I'm not proving it. If I have time, I will. It's probably something that if you really want to see the proof, you're going to have to come to my office hours. That's what we call the quotient rule. quotient means fraction, quotient, fraction, division. This is what we do when we have division and we want to take a derivative, we have to apply this rule. So it's going to be exactly what we were just doing, except a minus sign in between. And then at the very end, you'll divide the whole thing by g squared. G squared means you take whatever g is and you just square it. You don't take its derivative, you just square it. So whatever the denominator is, you're going to square it and put it on the bottom. So what I'd like to do now is I'd like to go back to the book, right? The book had this for the product rule. Let me make some room here. Here's what the book had for the product rule, right? And I already showed you it's different than what I presented you. Agreed? Like it looks different than mine. We could look at this as being f times g prime plus g times f prime. That's the way the book is looking at it. Okay, let's look at what the book says you should do for quotient rule. Right here. Here's what the book says you should do. So I'm going to write it down in a different way. What they want you to do first is g, then times f prime, right? G times f prime, then subtract from that f and then times g prime, right? F and then g prime, and then divide the whole thing by g squared. So here's why I present it the way I presented it to you. When I did this, going to quotient rule was basically the same thing, right? Except the minus sign, and then divide by g squared. So there's not a big difference between what I presented you for the product rule and the quotient rule. But if you look at the book, if first you memorize the product rule, right? Fg prime plus gf prime. And then you have to go memorize the quotient rule. And doesn't this look completely different than that one? I mean, look, instead of f prime g, it's gf prime, and then minus fg prime. That's different than this, divided by, I don't know, it just, when I was a student, I learned it the way the book taught it, this and this. And then I realized, look, I mean, you can rearrange things. I think it's easier to memorize this one and this one because they're so similar to one another. And so I've never understood why authors present it this way. I've never understood it. Almost every textbook I've ever looked at, they've done these two formulas. And I can't tell you why. So what's interesting is when I give a test, I'll see students who use this product rule and this quotient rule, which tells me they probably did a lot of tutoring. They got a lot of tutoring because they went and the tutor basically used that formula instead of using what I presented in class, which is not, it's not wrong. It's an indicator that what I showed in class, they went and learned it somewhere else. They didn't learn it in class. I don't care. You're not going to hurt my feelings. Just learn it. Okay. Either way, get it right. Okay. So let's do one of these. So here we go. What if we have this function f of x equals, let's go x cubed plus 1 over x squared minus x. Now, do not confuse this with the problem I gave you last class. Let me see if I can find it. Here, remember this one I did in class where I had these 3 terms over x, and I told you, no, you cannot just take derivative of the top and bottom separately. You can't do that. You have to actually split this up into 3 separate fractions, right? We have to split it up into 3 fractions. Here, we can't split this because we have 2 terms on the bottom. We have 2 on top, 2 on the bottom. If we had just 1 on the bottom, right? If we had just this, then we could split that up into x cubed over x squared plus 1 over x squared. And we could do what we did last class. Does that make sense? If we didn't have that x there, that's what we would do. But because we have a minus x, a second term, we have to do something else. So we're going to realize, right, that we have a numerator, that's our f, our denominator, that's our g. And we're gonna apply the quotient rule. Let me go back to the quotient rule. Because you know how on the product rule, I told you like it's the derivative of the first times the second plus the derivative of the second times the first. I'm gonna do the same thing for the quotient rule. I'm gonna kind of write how I think about the quotient rule. It's derivative top times bottom minus derivative bottom times top all over bottom squared. So again, when I'm thinking quotient rule, I'm not thinking F and G. I'm thinking I'm going to take derivative of the top, multiply it times the bottom. But I'm going to subtract from that the derivative of the bottom, then times the top. And then I'm going to divide all of that by the bottom squared. I think it's better for you long-term if you think about these rules in that way, from that perspective, than from like, you know, F prime G minus G prime F over G squared. Like that's great, but as you'll see later, it's not so simple to label things F and G. It gets a lot more complicated. So, you know, with me? We going? We doing this?
Is it because the variables will sometimes change? Like instead of F and G, it'll be like H and like another letter.
Yeah, you could be working a problem where F and G have already been used for something else, right? In fact, I've been doing it subtly. I've been calling the function F, but then I've been calling the top F. That's not right. I mean, technically, but again, I'm trying to see how this quotient fits into the formula. So I'm calling the top F and G to match the formula, even though the original function is called F. So yeah, we start to get into problems with letters if we just memorize, if we think about the formulas only in terms of F and G. Okay, so you ready? Let's do it. I've got the quotient rule right here. Here it is. Paste it up here. All right, here we go. So my derivative should be, I'm going to do it symbolically first. I need to take the derivative of F, the derivative of the top first. So I've got to take that x cubed plus 1, and I've got to take its derivative. Then I'm going to multiply that times the bottom function, x squared minus x. I'm going to subtract, not add, because I'm doing quotient rule. And then I'm going to have to take derivative of the bottom function, and then multiply that times the top function, and then divide the whole thing by the bottom function squared. F prime times G minus G prime times F over G squared. That's everything filled in, right? Just two derivatives to take, that one and that one. Here we go. Derivative of x cubed plus 1 is
3x squared.
x squared, that's it, right? 3x squared. And then we still have in parentheses, x squared minus x. Has to be in parentheses because this would distribute through, okay? Then minus over here, derivative of x squared minus x is
2x minus 1.
2x minus 1, good. In parentheses, and then times the x cubed plus 1 in parentheses. And then all of this over x squared minus x squared. And I'm just going to leave it like that. That's the raw derivative. That's the raw derivative. For this one, I'm going to clean it up. Okay, just so you can see me clean it up. I'm going to now just do algebra. I'm going to distribute. And on this one, I'm going to have to FOIL this all out, right? Like all this multiplication. So this is what I would get. I would get 3x to the 4th minus 3x cubed. And then I'm going to go ahead and distribute these. And I'm going to pass the negative sign through all of them. So I'm going to do this all in my head. 2x squared times x cubed is 2x to the 4th. But then I need to subtract it. And then I'm going to have 2x times 1, which is 2x, but then I need to subtract it. And then I have negative 1 times x cubed, which is negative x cubed, but then I need to subtract it. So it becomes added. And then -1 times 1, that gives me -1, but I need to subtract it, so it adds it. And that's all over the bottom squared. I'm not going to multiply out the bottom. I could, but I'm not going to. And then I'm going to collect like terms. These two are like terms. 3x to the fourth minus 2x to the fourth is x to the fourth. I have minus 3x squared plus, minus 3x cubed plus x cubed is minus 2x cubed. And then I just have an x term minus 2x, and then I have +1. And that should be the top cleaned up over the bottom. There's my derivative.
But you don't have to solve the squared in the bottom.
You don't need to. I mean, you could, it wouldn't be
Yes.
wrong if you followed
Because
it out.
if we do it, this may be wrong, but if we do it like the first one, it would be x to the power of 4, and it wouldn't affect like the top since it has
No,
like.
you couldn't cancel anything because
Okay.
they would be separated by addition and subtraction, so you couldn't cancel anything out. All right, good. Okay, let's keep going. Why don't I give you a minute to do that one? I'll just throw the quotient rule down here for you, just so you have it. Okay, I'll give you a few minutes. Enjoy. Don't worry about cleaning it up. Just give me a raw derivative. If you finish the derivative, I'm going to ask the second part, the second question there. You can start thinking about that. Okay, I think that's probably enough time to get the derivative. So let's see here. F prime of x I'm gonna write it symbolically first. I need to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. And just to make sure you don't make a mistake here, when you square, if you were to square this, you do not square each one. You have to FOIL it out. So don't turn this into x plus 1 because that's not what it is, right? Okay, so now I continue. Any questions on me just setting it up like symbolically? Ready to take derivatives, derivative here, derivative there? Now, I've been through this with you now several times. The derivative of x is 1 over 2 root x. I still need to multiply that times the the bottom one, which is square root of x plus 1. Then minus, now when I do the square root of x plus 1, take its derivative, I can do them individually. I know that the derivative of 1 is 0, so it won't factor in. But the derivative of the square root of x is again 1 over 2 root x. But then I still have to multiply that times the square root of x. And I still have to divide all of that by square root of x plus 1 squared. So let's do a quick poll. Did you get that answer, yes or no? Just be honest. I don't care. I'm not going to hold it against you. I want to see how many of you got that. Okay, so quite a few of you did. A few of you had some issues with it. Does anyone want to ask a question?
So it stays there, right? Because I
Sorry?
try to, it stays that, like, that's the answer, like the final answer.
This is like a raw derivative. Okay, this is very raw. We haven't done any algebra to it. This would be fine. There are things that happen algebraically, like if you start to play with this, these root x's could cancel. You could even distribute this through, but I'm not going to. I'm just going to leave it like this. Okay, now look at the second part of this. I said, hey, find the equation of the tangent line to this curve, y equals this, at x equals 4. Okay, well, we just went down this road a minute ago, right? Equation of tangent line, we know we need y minus y1 equals m times x minus x1. All right, well, here I didn't give you a point, did I? Not a point. I just gave you the x coordinate, right? So you know that the point we're talking about, the x coordinate is 4. What's the y coordinate? How are you going to get the y coordinate?
Plug it into the original.
Plug it into the original function. If you plug 4 into this, let's see what we get. And that will be a point on the original curve, won't it? So we plug in 4, it's square root of 4 over square root of 4 plus 1. Let me clean that up. That's 2 on top. And then we have square root of 4 is 2, 2 plus 1 is 3. So that's the point, isn't it? So what that tells me is my equation looks like this now. Y minus 2/3, that's my y1, equals some slope, which I have yet to determine, and then x minus 4. So this m is going to be the derivative. Notice I'm using y prime because my original function was called y, not f of x. I want the derivative at x equals 4. But I know the derivative, don't I? I know the derivative. The derivative of that function y is actually this whole thing right here. I just need to plug 4 into it. If I plug 4 in for x, I will get the slope of the tangent line. So using this, let's plug 4 in. Questions?
Why are you plugging in 4, not 0?
Why am I plugging in 4, not 0? Because I'm asking for the equation of the tangent line at x equals 4. So the x equals 4 determines what the x value is. If you look at the one we did before, where was it? Right, remember when I asked for the equation of the tangent line, I gave you the 0.00. Here I'm giving you what x is, and that's why we use 0 in the previous example.
Oh, okay, that makes sense.
But I also gave you the y coordinate. You all notice that? I gave you in this one the x and y, right? Well, where does this y come from? Just taking 0 and plugging it into the original function. If you plug in 0 here, you'll get sine of 0, which is 0, times cosine of 0, which is 1, and 0 times 1 is 0. That's why the y coordinate is 0. You didn't need to know that, though. I gave you that information. On this problem, I'm only giving you the x coordinate, which means you had to come up with the y coordinate by plugging the 4 into the original function. Then to find the slope of the tangent line, you have to plug that 4 into this derivative. 1 over 2 root 4. Root 4 plus 1 minus 1 over 2 root 4 times root 4 all over square root of 4 plus 1, that quantity squared. Well, good thing I gave you 4, right? Square root of 4 is an easy number, right? So square root of 4 is 2. So I'm just going to rewrite this as 1 over, let's see, 2 times 2 is 4. So 1/4. And then square root of 4 is 2. 2 plus 1 is 3. Minus, okay, this is, these root 4s just cancel. So that's just going to be minus 1/2. And then that whole thing is divided by 2 plus 1 is 3, but 3 squared is 9. So I get 3/4 minus 1/2 all over 9, which is 3/4 minus 2/4. I'm about to combine the numerators together. So I got a common denominator here. So this gives me 1/4 divided by 9. And if we look at this as a fraction divided by a fraction, you can multiply by the reciprocal. This is the same as 1/4 times 1 over 9, which is 1 over 36. That's what m is. So I think I have my equation. Isn't this fun? 1 over 36, x minus 4. That is the equation of the tangent line to this curve at that point. Y'all ready to check it? Let's check it. Let's graph it. Let's see if we did it right. Okay. Questions? So there's a big picture here, right? If somebody gives you a function and an x value and asks you for the equation of the tangent line, you should first be able to use that x value to get the y value to have a point. And then you use this equation, right? This point slope equation, this equation. You now have the point x1, y1. You just need the slope. So you go find the derivative and you plug the x value into that derivative, and that'll give you the slope there. Let's graph it. Okay, the original function was square root of x over, nope, over square root of x plus 1. There's the original graph. Now, we were looking at the point 4 2/3, right? That point does live on the graph. There it is. And then we found the equation of the tangent line to be y minus 2/3 equals 1/36 x minus 4. That always makes me happy when it looks right. There, if I graph it like that, you can, I think you're convinced that is the equation of the tangent line, yes? All right, we're rocking and rolling. Should I crank it up a little?
Yeah.
Okay. Y equals x squared sine x over x squared plus sorry, I was thinking how bad I want this. X squared plus 1. There we go. Have you all ever heard the phrase turning the screws? Turning the screws. Have you ever heard that before? I believe it goes back to medieval times when they had torture devices where they would get people to try and like admit to something or like change religions or something. They put them in like they put their head in like a vice and they just start turning, squeezing their heads, and then they would be like, admit that you did this or whatever. It's torture. And so they would turn the screws to make it worse and worse and worse. And then eventually they'd either give up or die, right? So that's what's going to happen now that we start getting these rules. We're going to get the rules and then we're going to start turning the screws. We're going to start making the functions harder, more complicated. We're going to start adding different elements and layers to it, like this one in particular. Do you all see that ultimately you have a quotient? You have a top function and a bottom function. You all see that? So you already know you're going to have to do the quotient rule. You're going to have to take derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom square, right? That's what you have to do. But when you take the derivative of the top, you look at it and you go, oh crap, what is the top? It's a product, right? Which means when you get to the step that you have to take derivative of the top, you're going to have to do the product rule. So we're going to have, in this problem, we have a quotient rule. And within the quotient rule, we have a product rule. Okay, so let's not get ahead of ourselves. Let's just apply the rule. Okay, here comes the rule. So I'm going to just write this symbolically. First thing I have to do, top is F, bottom is G. I need to take derivative of the top, x squared sine x. I need to take its derivative, then multiply that times the bottom, and then subtract from that now the derivative of the bottom, and then times the top, no derivative, and then put it all over the bottom squared. Okay, we have two derivatives to take. Are there any questions? Two derivatives to take. Do we all agree that this one is easy? 2x, we're done. This one, I don't know if we're happy. I'm happy, but I mean, you're thinking, oh crap, I got to do a product rule, right? I've got to do a product rule. I have a product. I cannot do those separately. So that means over here on the side, I've got to figure out what the derivative of x squared sine x is. And then I apply the product rule to this, which would mean I take the derivative of the first one times the second one plus the derivative of the second one times the first one. Forgot the derivative. You see, I've got a product rule that lives inside of a bigger quotient rule that I'm in the middle of. And this would now become over here 2x sine x plus, now this is going to turn into a cosine x when I take the derivative. So it'll be cosine x squared. I'm going to put the x squared in front of the cosine. Questions on that? Everyone clear with this over here? That is what the first yellow piece turns into, this over here. So I'm ready to continue my derivative here. This will be everything I just found, 2x sine x plus x squared cosine x. That was a derivative of the top. Now times the bottom in parentheses. Minus, now you all said that this was an easy one. Well, I said it was easy. I think you agreed. The derivative of that's just 2x. And then times the other one. I technically don't need parentheses. Why don't I need parentheses? Why do I not need parentheses around any of this?
There's no pluses or minuses.
No pluses or minuses. So it's just multiplication. So you don't need a parenthesis. Now, it would not be wrong to do that, but it wouldn't be necessary because you never have a distribution over the addition or subtraction because there is no addition or subtraction. All of that over the bottom squared, and that's your raw derivative. We're starting to have fun now. Okay, how about this one? F of x equals x cubed over x squared plus 1. Find f double prime of x. Shit. So I've got to take the derivative. And then after I take the derivative, I've got to take derivative again. You know what? Hold on. We're not prepared for this yet. Make it x minus 1 on the bottom. Sorry. We would have had an issue there. Well, not a big issue, but not a nice one. All right, you ready? Let's do it. Let's do it. First, let's do the first derivative. So let's see if I can do this one without actually having to write it out symbolically and just start doing it mentally. So I need to take the derivative of the top, right, which is
3x squared,
3x squared. Now times what?
x minus 1.
X minus 1, and I'll need that in parentheses, right? Minus, now the derivative of the bottom.
It'll be 1.
1, good, yeah. That's nice, isn't it? The derivative of the bottom is just 1. Take derivative of each piece, right? Derivative of x is 1, derivative of -1 is 0. And then I have to multiply that still by the top. And then I'll take the whole thing and divide it by the bottom squared. Now, we have to clean this up because we need the second derivative. So let's clean it up. I'm going to distribute here. So we will get 3x cubed minus 3x squared minus x cubed all over the bottom, which is x minus 1 squared, right? Which is 2x cubed minus 3x squared all over x minus 1 squared. Questions? That's your first derivative, right? That's your first derivative. I want the second one. So we got to go and differentiate again. So when I say differentiate again, I need to look at this and take its derivative. And it's a quotient, isn't it? I have another quotient. I have a top function and I have a bottom function. So I got to do the same thing. Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom square. Derivative of the top times bottom minus derivative of the bottom times top on the bottom square. Has anyone here ever seen that that movie Kill Bill 2, the second one, Kill Bill? Am I aging myself here? Yes, Kill Bill. Uma Thurman. No, you haven't seen it. Really?
I've only seen the first one.
That old, huh? So in Kill Bill, she goes and she meets with this kung fu master out in like the mountain regions of somewhere. And that's where she learns all her like martial arts skills and stuff. And she's training like really, really hard out there. And he's just abusing her. You just have to see the movie. And all she's doing is learning how to fight and punch, blah, 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 all this stuff. For years, she's out there doing this. And she's doing it so much that she's like waking up in the middle of the night, like punching, right? Like just like punching, because that's all she does all days. So I always think about that when I'm thinking about these rules, because it's almost like you want to be doing this so much mentally that you're like, waking up in the middle of the night going, derivative of the top times bottom minus derivative of the bottom times. Like, I don't literally mean that, but that's how you want to get to the point where you're not having to look it up. Like it's here, right? All right, here we go. So let's just write it down. I'm going to do it symbolically on this one. I need to take the top one. And I need to take its derivative. And then I need to multiply that times the bottom. But the bottom is x minus 1 squared, right? So that would be correct to write it this way. There's the top. I need its derivative times the bottom. Then minus, now be careful here, be really careful. The bottom is actually x minus 1 squared, but I need to take its derivative, right? I need to take derivative of that and then multiply it times the top. And then all of that over the bottom. Here's the bottom, right? But I have to square the bottom. So I'm going to be squaring something that's already squared. So it's going to go to the 4th power. But I'm just showing you what's happening here. Any questions? What do you all think about the yellow? Are you going to have any issues with that derivative? Shouldn't, right? This is just power rule. You can do them individually. That should be okay. The second one, though, the one here in blue, this derivative is something tricky we haven't seen before. Right now, I do not know, you do not know how to take the derivative of something raised to a power unless it's just x to a power, right? If it's x squared, you know the derivative, but x minus 1 squared, we have not learned anything about this yet. So what I'm going to have to do this problem is I'm going to have to expand out x minus 1 squared, FOIL it out, and it becomes x squared minus 2x plus 1. After I expand it, now I'm happy taking the derivative because I can just do each one individually. Does that make sense?
Can you
Could
do
we?
product rule on that one?
I'm sorry?
Uh,
Can you what?
the product rule.
Could I have done the product rule? Yes. Could I have looked at x minus 1 squared as x minus 1 times x minus 1 and then applied the product rule? Yes. But I think it's easier to just expand it and then just do each one. But that would give you the same answer. I'll show you if you'd like. What is, let's write the next line down. Okay. What, there was someone else said something else. Was there another question or no?
Yeah, I was gonna ask if it would have been wrong to expand it when we're doing the first derivative. To expand the
down
bottom,
here?
the denominator, yeah, to
Yeah,
expand
in
it.
the beginning, you could have expanded it right here, and then on your next line had that right here, and on the bottom here had x squared minus 2x plus 1
Okay,
squared. So you get the same result.
Okay.
Okay, so here I go. I'm gonna take derivative of this first one, which is 6x squared minus 6x. That okay with everyone? In that top left yellow one? Then I still have x minus 1 squared minus, okay, here that blue, I expanded the x minus 1 squared, and now when I take derivative of that, that's just 2x minus 2. And then times 2x cubed minus 3x squared. And then all of this is over x minus 1 to the 4th. I just went ahead and squared the squared and made it 4th power. I think it was David that asked, instead of doing this in green and expanding it, could we have done this, right? Okay, so let me show you. If you did that, the derivative of this, right? The derivative of that, the derivative of this product rule would be the derivative of the first one, which is 1, times the second one, plus the derivative of the second one, which is 1 times the first one. And if you clean that up, that's just x minus 1 plus x minus 1, right? Like that. and you get 2x minus 2, which is exactly the same thing as what we got there. So either way would have worked. Expand it, then take the derivative, or do the product rule, and you would have got the same result. I would say whatever you feel like here. Next class, we're going to find out a way to do that without expanding or without doing this. Because right now, if I asked you, right now I was asking you to find the derivative of this, right? And so what we did is, we expanded it, or you can treat it like a product rule. But if I change that to the 21st power, well, you sure as hell don't want to expand it, right? You don't want to expand that. X minus 1, 21 times. And you sure as heck don't want to do a product rule that involves 21 products, because that would be a disaster. That'd be a big mess. So this is an open question. We don't know how to do this yet. This will require chain rule. That's our last rule that we learn, and the hardest rule, the most confusing rule. Students have a real hard time with chain rule. Okay, so stay tuned for that one, that x minus 1 to the 21. Stay tuned. All right, I want to show you another one. So we should all be comfortable with this idea right now, that if I put tangent x here, that the derivative of this is secant squared x. And the reason you should be comfortable with that is because I told you that, right? I told you that's what the derivative was. And I said, just believe me, right? Believe me, but I didn't prove it to you. I'm going to show you why it's secant squared x now. And it's going to be pretty simple for me to show now that we have the quotient rule, because I can rewrite tangent as sine over cosine. That's what tangent is, right? And now if I ask you for the derivative of that, you have a quotient, don't you? You have a top function and you have a bottom function. So let's follow the rule, right? I'm supposed to take the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared, right? That's the rule being applied to tangent. The derivative of sine is cosine, so I get cosine x times cosine x. And then I have minus the derivative of cosine of x is negative sine x. And then times sine x again. And then all of that is over cosine of x squared. Y'all see what's going to happen? The top is cosine squared x minus is plus sine squared x all over. I'm going to rewrite the bottom as cosine squared x. And the numerator is 1 from the Pythagorean identity from pre-cal, right? Sine squared x plus cosine squared x is 1. So this is 1 over cosine squared x, which you could also look at as being 1 over cosine x squared, right? That's the same thing. If I square this fraction, I square the top. 1 squared is 1. If I square the bottom, I get cosine squared. But what is 1 over cosine?
Secant.
Secant. So this is secant x squared, which is secant squared x, same thing. That's how you can prove that the derivative of tangent is secant squared. And you can also prove all the others. I didn't prove this one. Okay, I told you all already that if you take the derivative of secant, we had this earlier, secant x tangent x, that's the derivative. I told you, hey, you kind of need to know that. If you wanted to prove this, you could rewrite secant as 1 over cosine and then take its derivative. And you'd have a quotient. You'd have 1 on top, 0 on the bottom. So what would the derivative of the top be?
0.
0 times the bottom minus what's derivative of the bottom?
Negative sine.
Negative sine times the top. What's the top?
1.
1 over the bottom squared. Y'all following that? That goes away. Minus minus becomes plus, so we wind up with sine x on top and cosine squared x on the bottom. So how in the hell is sine x over cosine squared x equal to this? Well, all you have to do is this. Separate it out. That cosine squared on the bottom, write it as two cosines multiplied together next to one another and split it into two fractions. So if I multiply across the top, I get sine. If I multiply across the bottom, I get cosine squared. But individually, that's secant and that's tangent. If you just switch the orders, secant x, tangent x. You can do that. You can do that for cosecant. You can prove it the same way. And you can also do that for cotangent. You can just use the quotient rule. You don't need to, if on a test, you don't need to do that. Just go to the formula sheet and give me the derivative. How are we doing? Oh, we're almost out of time. Okay, well, that's it. You have the two rules, product rule and quotient rule. So now it's time for you to go do your homework. And homework wise, I don't think there's any restriction on what you should be doing here for 2.4. I did extend the deadlines for handwritten work to be submitted. So there's no deadlines coming up anytime real soon. Let me see here. I'm just looking here. Okay, I would say don't worry about 41 and 43. I wouldn't do those. I haven't really talked about those. And don't worry about 55 for now. Everything else, I think, is fair game. 47 is a little weird, but see what you can do with it. That's it. No test on Tuesday, right? Make sure you do this homework. When we return to do chain rule, like I said, chain rule is the most challenging, the most confusing. But if you cannot do, if you don't understand the product rule, if you don't understand quotient rule or the power rule, the rules we've talked about this week, chain rule is going to be impossible, right? You have to be comfortable with these rules in order to do well with the chain. So make sure you invest the proper amount of time in making sure you understand how to do everything we did this week. Okay. All right. We'll see you. Have a good one.
Can I ask you something at the end?
Do you have a question? No, I'm sorry.
Yeah, not about the class, like person. Yeah. So I arrived like a half an hour late, and now I'm gonna see like the recordings